When we look up at the night sky, we see stars, some dim, some bright, some massive. But what if I told you that there's a star so incredibly large that it makes our sun look like a tiny dot? A star so colossal that if it replaced our sun, it would engulf everything up to the orbit of Saturn. Meet Stevenson 2 to 18, the largest known star in the universe. Stevenson 2 to 18 is a red supergiant located in the Scutum constellation, and it is unlike anything we've ever seen. Its radius is estimated to be 2,150 times larger than the Sun, making it the largest star ever discovered in terms of volume. But what makes Stevenson 2 to 18 so special? How did it become so massive? And what will happen when it reaches the end of its life? Could it explode in one of the most powerful supernovae the universe has ever seen? Or could it collapse directly into a black hole? In this documentary, we will explore the life and death of this gigantic star, uncover the science behind its incredible size, and look at what its future holds. Get ready to journey into the heart of the cosmos, where the biggest giants of the universe reside. For centuries, astronomers have studied the stars, cataloging the brightest and largest ones visible from Earth. But it wasn't until the 20th and 21st centuries that we began discovering the true giants of the universe, stars so large they defy our understanding of physics. Among them is Stevenson 2 to 18, a red supergiant whose size challenges everything we thought we knew about star formation. Keycap 1, the man behind the name, Charles Bruce Stephenson. Telescope the discovery. In 1990, American astronomer Charles Bruce Stephenson was conducting a survey of red supergiant stars in the Scutum constellation. His research focused on a massive star cluster known as Stevenson 2, which contains some of the largest stars ever discovered. Among them, one stood out, Stevenson 2 to 18, an ultramassive red supergiant that dwarfed all other known stars. Milky Way historical impact. Stevenson 2 to 18 was originally underestimated in size, as its extreme distance made precise measurements difficult. Over time, improvements in infrared and radio astronomy confirmed its astonishing radius, over 2,150 times the size of our Sun. This discovery changed our perception of what stars could become at the end of their life cycle. Keycap 2, how do we measure a star size? Satellite antenna astronomical techniques. Measuring distant stars, especially red supergiants, is incredibly challenging due to their extreme distances. Stevenson 2 to 18 is about 19,570 light-years away. Dense stellar environments, making them hard to distinguish from surrounding stars. Massive, expanding atmospheres, making their edges difficult to define. Microscope methods used to measure Stevenson 2 to 18. Infrared observations. Since red supergiants emit most of their energy in infrared wavelengths, astronomers used NASA's Spitzer Space Telescope and other infrared observatories to study the star. Spectroscopy. By analyzing light signatures, scientists determined its temperature, composition, and radius. Parallax and luminosity comparisons. Using nearby reference stars, researchers estimated its true scale and distance. Through these advanced techniques, we realize just how enormous this star truly is. Keycap 3, how does Stevenson 2 to 18 compare to other giant stars? VS button comparing the titans. The Sun, 1 solar radius. Betelgeuse, 1,000 solar radii. VY Canis Majoris, 1 for 20 solar radii. Stevenson 2 to 18, 2,150 solar radii, astonished face. Fire fact. If Stevenson 2 to 18 were placed at the center of our solar system, its outer layers would extend beyond the orbit of Saturn. Stevenson 2 to 18 isn't just big. It's the biggest known star we've ever discovered. Keycap 4, why is Stevenson 2 to 18 so huge? Sun, the life of a red supergiant. Stevenson 2 to 18 is in its final evolutionary stage, a dying star rapidly shedding its outer layers. Hydrogen fusion has mostly stopped, and now helium and heavier elements are being fused, causing the star to expand dramatically. The larger the star, the shorter its lifespan. While the Sun will last 10 billion years, Stephenson 2 to 18 may live only a few million years before collapsing. Microscope theoretical limits of star size. Scientists once thought no star could exceed 1,500 times the Sun's radius. Stephenson 2 to 18 shattered this assumption, forcing astronomers to rethink the limits of stellar physics. But what happens when a star this massive reaches the end of its life? Summary of the historical background section. Heavy checkmark discovered 1990 by Charles Bruce Stevenson. Stephenson 2 to 18 was part of a massive star cluster in Scutum. Heavy checkmark measuring a star this large requires advanced infrared and spectroscopic techniques. Heavy checkmark, it is the largest known star, surpassing all other red supergiants ever discovered. Heavy checkmark, it's in its final stage of life and will soon undergo a catastrophic transformation. Rocket, next, we explore the incredible fate that awaits the biggest known star in the universe. Every star has a lifespan. The smaller ones, like our Sun, live for billions of years, slowly burning their hydrogen before becoming white dwarfs. But the largest stars, like Stephenson 2 to 18, burn bright and fast, meeting an explosive end. So, what happens when the biggest known star in the universe reaches its final days? Keycap 1. The last moments of a red supergiant. Glowing star, what's happening inside Stephenson 2 to 18? As a red supergiant, Stephenson 2 to 18 has already exhausted most of its hydrogen fuel. The core has begun fusing heavier elements: helium, carbon, oxygen, and eventually iron. But iron cannot undergo fusion to release energy, meaning the star has reached a dead end. Fire, the collapse begins. Once iron builds up in the core, gravity takes over. The immense weight crushes the core in a fraction of a second, triggering an event so powerful it can outshine an entire galaxy. This is the birth of a Type 2 supernova, one of the most violent explosions in the universe. For a brief moment, Stephenson 2 to 18 will release more energy than the Sun will in its entire lifetime. Keycap 2, the supernova, a cosmic explosion beyond imagination. Rocket, how big will the explosion be? A supernova explosion from a star this massive would be truly colossal, releasing more energy in seconds than our Sun will in 10 billion years. The shockwave will blast outer layers of gas into space, creating a beautiful nebula. The explosion will be visible from millions of light years away, possibly outshining entire galaxies. Milky Way, what happens next? The explosion creates and scatters heavy elements like gold, silver, and uranium across the cosmos. These elements will later form new stars, planets, and even life. From destruction comes creation. This is how the universe recycles itself. Keycap 3, the fate of the core. Will it become a black hole? Hold two possible outcomes. If the remaining core is above 3 solar masses, it will collapse into a black hole. If it is between 1.4 to 3 solar masses, it could become a neutron star, a super-dense, rapidly spinning stellar remnant. Telescope black hole formation scenario. Stephenson 2, 18's core is so massive that scientists believe it will collapse directly into a black hole, skipping the neutron star phase. The intense gravity will pull in surrounding gas, forming an accretion disk around the black hole. Shooting star, the aftermath. The result could be a stellar mass black hole or possibly a mid-sized black hole, something rarely seen in astrophysics. If the collapse is extreme, the explosion might create a gamma ray burst, one of the most energetic events in the cosmos. The biggest star in the universe may leave behind one of the most mysterious objects in the universe. Keycap 4. When will this happen? Hourglass, not on how much time does Stephenson 2 to 18 have left. Unlike smaller stars that live for billions of years, red supergiants only live for a few million years. Scientists estimate that Stephenson 2 to 18 is near the end of its life, but in cosmic terms, that could mean tomorrow or in 100,000 years. If the explosion has already happened, we might not see it yet, since the star is 19,570 light-years away. Microscope, can we predict when it will explode? Astronomers observe red supergiants for signs of instability, like sudden brightness changes and mass ejections. However, predicting exact supernova timing remains one of astrophysics' greatest challenges. We are cosmic spectators, waiting for the inevitable. Summary of the fate of Stephenson 2 to 18. Heavy checkmark Stephenson 2 to 18 will end its life in a powerful supernova, spreading heavy elements across the galaxy. Heavy checkmark, its core will likely collapse directly into a black hole, skipping the neutron star phase. Heavy checkmark, the explosion could happen in the next 100,000 years, or it may have already happened and the light hasn't reached us yet. Heavy checkmark, studying red supergiants helps us understand the life cycle of the biggest stars in the universe. Rocket, but what does Stephenson 2 to 18 teach us about the universe? And even our own sun? The universe is a vast laboratory, constantly shaping and reshaping itself. By studying Stephenson 2 to 18, we aren't just observing a massive star. We're unlocking secrets about how stars live, die, and create the very elements that make up planets, life, and even us. Keycap won the role of supergiant stars in the universe. Glowing star, why do stars like Stephenson 2 to 18 matter? They are factories of heavy elements. Everything from carbon in our bodies to gold in our jewelry was forged in a dying star. Their explosions seed galaxies with new material, helping form future generations of stars and planets. They shape the cosmic landscape, influencing nearby star systems with their intense radiation and gravitational fields. Microscope, studying red supergiants helps us understand stellar life cycles. What determines whether a star explodes as a supernova or quietly fades away? Improve supernova predictions. Can we predict when a massive star will explode? Learn about black hole formation. Do all massive stars become black holes, or are there exceptions? Without supergiant stars, the universe as we know it wouldn't exist. Keycap 2, what does Stephenson 2 to 18 teach us about our sun? Some would face the sun versus Stephenson 2 to 18. Unlike Stephenson 2 to 18, our sun is a main sequence star, meaning it is stable and long-lived. The sun will never explode as a supernova. It will expand into a red giant, then shrink into a white dwarf. Studying supergiant life cycles helps us understand how the sun's eventual death will shape the solar system. Globe showing Europe, Africa. How will the sun die? In about 5 billion years, the sun will expand to engulf Mercury, Venus, and possibly Earth. It will then shed its outer layers, forming a planetary nebula, leaving behind a white dwarf, a dense, cooling remnant. Telescope, learning from supergiants like Stephenson 2 to 18 helps predict the fate of stars of different sizes, gives insight into how planetary systems evolve over billions of years, could help scientists understand exoplanet habitability, what happens to planets when their stars reach the end. Studying the universe's largest stars also helps us understand the future of our own solar system. Keycap 3, the future of giant star research. Rocket, upcoming missions and observations. The James Webb Space Telescope, JWST, is revolutionizing how we see massive stars, detecting details we never could before. The Vera C. Rubin Observatory will help track changes in red supergiants, improving supernova prediction models. Future space telescopes may be able to study the final moments of massive stars in real time. Microscope, could we witness the explosion of a red supergiant? Some scientists believe a nearby red supergiant, Betelgeuse, could explode within our lifetime. If we catch it at the right moment, we may be able to study a supernova as it happens in unprecedented detail. With modern technology, we may one day witness the death of a massive star in real time. Summary of what we can learn from Stephenson 2 to 18. Heavy checkmark supergiant stars like Stephenson 2 to 18 are responsible for creating the heavy elements that form planets and life. Heavy checkmark, studying them helps us understand how stars evolve, explode, and influence their galaxies. Heavy checkmark learning about their life cycles helps us predict the fate of our own sun and other stars. Heavy checkmark advanced space telescopes will allow us to study these giants like never before, and maybe even witness their final moments. Rocket, the universe is full of mysteries, and the biggest stars may hold some of the biggest answers. In the grand scale of the universe, stars are born, they live, and eventually they die. But some stars, like Stevenson 2 to 18, leave behind a legacy that reshapes entire galaxies. They are the ultimate cosmic creators, building the very elements that form planets, moons, and even life itself. Keycap won the impact of Stevenson 2 to 18 on astronomy. Telescope what this star has taught us. Heavy checkmark it shattered previous size limits, proving stars can grow larger than we ever imagined. Heavy checkmark it gave us insights into the final stages of red supergiants and their role in shaping galaxies. Heavy checkmark it challenged our understanding of black hole formation, as its fate remains uncertain. Milky Way, how will we remember this star? Even after it explodes or collapses, Stevenson 2, 18 story will continue. The heavy elements it creates will travel across space, forming new stars, planets, and perhaps even life. It reminds us that nothing in the universe truly disappears. It only transforms. Keycap 2, the bigger picture, our place in the universe. Shooting star, what can we learn from giant stars? They are cosmic time capsules, helping us understand how galaxies evolve. Their deaths create the building blocks of new solar systems, including ones that may host life. They're a reminder that our sun, too, has a life cycle. One day, our solar system will change forever. Rocket, the study of stars, is the study of our own existence. Keycap 3, the final thought. The mystery of the universe continues. Globe showing Europe, Africa. What if there are even bigger stars? Stevenson 2 to 18 is the largest star we know of today. But what if there's a star out there even larger, waiting to be discovered? As our technology improves, we may find even more extreme objects, rewriting what we thought was possible. Telescope with every new discovery. We take one step closer to unlocking the deepest secrets of the cosmos. The universe is vast, mysterious, and constantly evolving. The question is, what will we discover next?